Hello to every one of you. Let's start off with the session where we'll be doing some practice questions in the chapter Properties of Solids and Liquids. It's a part of the revision course for JEE and NEET 2020. Let's start. So let's start off with the practice questions. Okay, so we are doing the practice questions on the chapter Properties of Matter or Properties of Solids and Liquids. Okay. Let's start from the first question, right? So your question number one is, this question is from NEET 2017, right? You have a spherical object. With bulk modulus, B. What we do is, it is subjected to a uniform pressure from all sides. It is subjected to a uniform pressure, let's say P. The result of this is the practical decrease in the radius is. You're basically being told in the question that on compressing, the radius changes. Because of the compressive force P, the radius changes. Okay. We need to find out what is the decrease in the radius, or if this was right R, right, and let's say this is the decrease is, let's say, or let's say this was R1, let's say this is R2. So we need to find out what is R1 minus R. Yes. So can you try this out, Atul? Any hints, any approaches that you would like to suggest? Yes.
So I think Bernoulli's theorem, we can use Bernoulli's
Here we will use a formula for bulk modulus. Do you know how do you give the formula for bulk modulus? Yes. Bulk modulus
theorem.
is
Yes, force by area.
right. Stress per unit strain. What strain?
Yes, sir,
Volumetric
per
strain.
unit. Delta V by delta.
Correct.
Yes,
Now,
sorry, delta V by T. Yes, sir.
this is the one.
Yes, sir.
Okay. Now try to think. Now try to think that from this, what will be the value of delta V by V? It will be equal to force per unit area whole by bulk modulus. Am I correct?
Yes, sir.
Right? Now we know that how are V and R related to each other? V is equal to 4 by 3 pi r cube, correct?
I agree.
Now we
Yes,
have
sir.
read a formula. Try recalling that when Z is equal to x power A into y power B, right? Upon,
Yes.
or let's say we'll take just x power A by y power B, then the fractional change in Z. I am saying the fractional change in Z. Fractional change in Z, that is delta Z by Z, where delta Z is the change, right? this is given by a times of delta x by x minus b times of delta y by y. We have read this, right? So according to this formula, now tell me what should be the value of delta v by v from this expression. This is a constant, right? So we generally ignore all the
uh,
constants. If there was a k here,
yes, sir.
it would not have any impact on this fractional change equation. Now tell me what would be the fractional change equation for volume. Yes, fractional change in volume is
Uh,
equal to,
uh, 3 delta R by R.
absolutely correct, absolutely correct. So this gives me the relation between fractional change in volume with fractional change in radius, right? Correct.
Yes, sir.
Now I can write from here this expression that, okay, from this expression I will write delta v by v is equal to force acting per unit area whole by b. First of all, force acting per unit area is nothing but it is pressure, right?
Pressure.
Force acting per unit area is pressure, right? So I can replace this F by A by an by the P value, right? Correct.
Yes, sir.
Now P by B. Now P by B will be equal to uh, 3 delta R by R. Am I correct?
Yes, sir.
R by R. Am I correct?
Yes, sir.
Okay, so actually, I'll try to reframe the question. They are asking what is the ratio of change in radius upon original radius? Because they see, this is the word they write, the practical decrease in radius. Practical decrease in radius. These are the words that they write when they are asking this value. So I believe they're trying to ask delta R by R and not just delta R. Okay, they're trying to ask what is delta R by R, right? So can you find out what's delta R by R from this expression? Yes, is equal to P upon
Uh,
Pp,
uh, 3
right?
by 3, yes, sir.
Now have a look at this question. Let's say for 15 seconds, write it down in your note. Once you are sure that we can go ahead, we'll go ahead. Otherwise, if there is any query, let me know. Yes, Atul, go ahead. Anything, just go through it. Go through it. If there is anything you want to ask, feel free.
No, sir. Question is clear, sir.
Here, okay, let's take the next one then.
Yes, sir.
So here is your next question, right? The next question is saying you that actually this is a kind of interesting question and might be asked in exams, right? So I'm telling you how. So see, the question says that there is a cylindrical vessel of radius r. So I'll draw the question figure maybe. Please note it down. There is a cylindrical vessel of radius r. Let's say you have a vessel of this sort. It has radius r. Let's say if I'll first mark the center. Let's say this is the center and we have this as the radius, right? So we have the radius as r. Now we are being told that, okay, just a second. So yeah, so we are being told that it is rotating about its vertical axis. So let's say if this is the axis, the central axis, it is rotating about this axis, this one. right? With an angular velocity of omega, with an angular velocity of omega, right? It is asking that when it does so, what is the difference of height? What is the difference of heights of what is the difference of heights of liquid at center, liquid at center and at the edge. So this is the center, right? Here's the center, right? And here are the edges. So it is observed that water inside takes a paraboloid kind of shape, a paraboloid kind of shape. So something of this sort, right? We want to find out what is this difference. So this one. Is the question clear to you?
Yes, sir.
There is a cylinder, right? The cylinder is rotating. The cylinder is rotating about the central axis, and its rotational angular velocity is omega. Its radius is r. When you start rotating it, it is observed that it takes a paraboloid kind of shape, right? The fluid goes down in level from the center, right? And it rises up in level at the edges. So you need to find out what is this difference in length between the center and the edges, right? This h needs to be found out, right? Any idea how should we go for it, Atul?
No, sir.
There is an equation called uh, which is used for energy conservation in fluids. Do you know its name, which we read in this chapter?
Bernoulli's theorem.
Absolutely correct. Absolutely correct. Very good. See, you have Bernoulli's theorem. So let's try and apply Bernoulli's theorem in this. See, always remember, whenever you're dealing with fluids, no, and you have to deal with fluids at one section and at another section, and they are linked by some medium, right? And they are linked. Let's say you have a pipe where liquids are linked by this pipe at two points, or let's say the case of this sort, right? Or let's say we have a tank and a hole in it at the bottom. So all such kind of cases where we are, let's say, considering point 1 and 2, you're also considering point 1 and 2, or case of this sort where this is point 1, this is point 2. All such cases where liquids are in continuum, right? Where liquids are in continuum, where the liquid at point 1 and point 2 are connected. At all such places, you can use this equation. What? Which one? Bernoulli's theorem. Which one?
Bernoulli's theorem.
Bernoulli's theorem, right? So let's say,
Bernoulli's.
yeah,
Yes.
let's say one of them, one point is named as 1, the other is 2. So how is Bernoulli's equation given as? P plus half rho v square,
Half rho v square
rho g
plus
is a
rho gh constant.
absolutely correct.
Yes, sir.
Now I will write this equation for part 1 and part 2. See here, P1 plus half rho V1 square plus rho G H1 is equal to P2 plus half rho V2 square plus rho G H2. Can we write this? Right?
Yes, sir.
Now what to do after this? Let's substitute the values, right? Let's substitute the values. So we are basically supposed to find out the difference in height, right? Difference in height. But see, one very important point. Both of these heights are actually from the ground almost at the same level. So initially both of them from the ground are because are both of them at the same level, right? So this term, the average height, so this difference is so small that I can take that this difference h1 minus h2 is almost zero, or I can take that h1 is nearly equal to h2. I can take h1, so let's say this is h1, the distance from the ground, and this is h2, this difference is almost zero, means you cannot consider h over here. That's the point. So I'll cancel out these terms. Okay, now you can ask that, sir, why are we then considering this H? This H is because of the pressure difference that develops there. This H is because of the pressure difference that develops in this zone. Why does the pressure difference develop? Because whenever we are rotating any fluid, what kind of force do you think should come into action? Centripetal force and centrifugal force, right?
Yes, sir.
Centrifugal and centripetal forces. So those forces are the ones which cause the liquid level to drop in the center, whereas to remain drop in the center and to rise in the edges. Right? That is the reason.
Yes,
That is the reason. That is change of forces or change of pressure which is causing this to happen. So the reason for the difference in height is this difference in pressure, is this difference in pressure, not the gravity, not the gravity. Are we clear that why am I cancelling these gravity terms, Atul? Because
yes, sir.
the
Yes, sir.
difference in height is not because of gravity. The difference in height is because of difference in pressure. Are we clear
Okay.
on this,
Yes.
Atul?
Yes. Yes, sir.
And pressure difference is because of the centripetal and centrifugal forces acting on the liquid, right? So
Yes, sir.
this is the point. Yeah, this is the reason for which I have cancelled out this term, right? Okay, now let's take this up. So we have H1 is equal to H2. Now I'll write this equation as P1 plus half rho V1 square is equal to P2 plus half rho V2 square, right? Now I can write the value of P1 minus P2 is equal to half of rho V2 square minus V1 square. Am I correct? Are we correct, Atul?
Yes, sir. Yes.
Now, do you know about this that whenever if this rod is if this entire liquid column is rotating in such a scenario, we can write V is equal to R omega, right? Where R is the distance of that point from the center. Have you read this in rotational motion, right?
Yes, sir.
Now,
Yes.
what about this point, central point 1? For this point 1, what is the distance of this point from the center? Distance of point 1 from the center. 0,
Yes, sir. Zero.
right? It is situated
Yes,
at
sir.
center itself, right?
At the
So
center.
at the
Yes.
center, so the velocity of point 1 is therefore equal to 0, right? What about the velocity of point 2? R omega, because it is at a distance of r from the center,
Uh,
right?
yes, sir.
We are giving that
Yes, sir.
substitution values to v1 and v2 to get p1 minus p2 is equal to half rho r square, right?
R
And
R
we
square
have
omega
omega
square.
square minus 0 square, right? Clear?
Yes, sir.
Okay. So now we
Yes,
will
sir.
have, yeah, so great. So now we will have the pressure difference is given by H rho G, right? Pressure difference is given by H rho G, correct?
Yes, sir.
Let's write that here.
Yes, sir.
We'll have half rho r square omega square is equal to H rho G. So how will we give H? So this rho and rho will get cancelled on both sides, right?
Yes, sir.
So we'll have, what should be the value of H? Tell me. H is equal to
Uh, R square omega square by 2G.
r square omega square by 2g. Okay. Is the question clear? Is the solution approach clear to you, Atul?
Yes, sir.
We have taken Bernoulli's theorem, right, and tried to expand or just substitute the values after this expression, right? Just taken that expression for Bernoulli's and one by one we have substituted the values, right? Go through it, write it down,
Yes, sir.
and as you're done, let me know. Yes, Atul, should we go ahead?
Yes, that's yes, sir.
Okay, right. So take this next question. Here's the question. The question is from NEET 2018. I'm reading out the question. It says that there is a small sphere of radius r. So you have a small sphere of radius r, which falls from rest in a viscous fluid, right? It starts falling in a viscous fluid. It says as a result, heat is produced due to viscous force. Heat is produced as it starts falling. Heat is produced due to viscous force, right? Now, as the heat is being produced due to viscous force, the rate of production of heat, that means, let's say if heat produced is Q, then dQ by dt, rate of production of heat when the sphere attains its terminal velocity is. This is what you need to find out. When the sphere attains its terminal velocity, that means when the velocity becomes equals to V terminal, what is the rate of production of heat? Tell me your approach first of all, Atul. How would you go for this question? Do we know what is the terminal velocity expression,
Uh,
by the way? Or do we know
yes, sir.
how does it depend on radius? R square, right?
Hmm. R square.
Correct?
Yes, sir.
Okay,
Two
great.
one.
R,
Yes, sir.
now it depends on R square. We know this one fact. What are we being told? We want to find out what is the rate of heat production because of viscous force. Correct? Correct?
Yes, sir.
Okay. Think about it. Think about it. First, think about it, then I'll tell. Yeah. Do you know one thing that whenever there is some force acting on a body, let's say there is a body which is moving, right, with velocity v, and there is some force acting on this body F. For such a body, how is the value of instantaneous power given as?
Uh,
We have read this in one of the classes, instantaneous power.
yes.
Instantaneous power is the, would you like to complete my statement? It's the dot product of force and velocity. Please take this down. A superbly important concept, Atul. Very important. Dot product
Yes.
of force and velocity.
Force and velocity.
Yes, dot product of force and velocity gives you instantaneous power, right? Instantaneous power. And here we have dq by dt. dq by dt is nothing but instantaneous power. Why? Because power is rate of change of heat, right? Power is rate of change
Yes, sir.
of doing
Rate of
work
change.
or rate of change of heat, right? So the power generated because
Hmm.
of some heat will be equal to rate of change of heat. Am I correct, Atul? Is it clear?
Yes, yes, sir.
So I can write power is equal to dq by dt is equal to, yes, is equal to, tell me, F dot V. Correct?
F dot B.
Now
Yes, sir.
we know, do you know the expression for viscous force? 6 pi eta RV.
It's by
Correct?
the RV.
Right? Okay.
Yes, sir.
Now this velocity, terminal velocity expression is directly proportional to R square. Correct?
R square.
Right? Now
Yes, sir.
we are supposed to find, actually no, in the question it does not directly say that what is the expression for change in rate of change of heat. The real question is how does this change of, how does this change of force, change of power, or sorry, change of heat, that is power, depend upon radius, depend upon radius. So on which power of radius does it depend? That is the question. So they are asking you on which power of radius does it depend. You are given with the options r power 5, r square, r cube, and r power 4. Yes. Any options would you would like to choose, Atul? How would you find out? Yeah, go ahead.
Um, so
Power.
I think R power 3.
Let's see. Power is proportional to force into velocity, right? Force is
Yes,
proportional
sir.
to force is proportional to r into v, right? And v can be
Mm,
directly written as this way. So we have r into v square. Am I correct?
yes, sir.
Now, v is proportional to r square when it is equal to terminal velocity. Correct? Correct?
Yes,
Because
sir.
we are talking about the condition when velocity has become terminal velocity, right? So we will have, instead of v, we can write r square. Correct?
Yes, sir.
Tell me, what does the proportionality yield to? R power
R power 5.
r power 5. That is option number,
First option.
first option, option A. Easy?
Yes, sir.
Atul? Clear?
Sir, can you explain? Yes, can you explain that step? Last step again, sir.
See, all I did is I know from this expression that power is depending upon r and v,
Okay.
and
Yes, sir.
velocity is depending upon r square. So I want to find out what their product depends
Hmm.
on. So I'll have f into v depends upon rv into r square.
R,
Now
R square. Okay, yes, sir.
r cube into,
Now understood.
is it clear now?
Yes, sir.
And
Yes, sir.
when I write r cube
Uh,
v, we know that v depends upon r square, and therefore this expression becomes
hmm.
fb, or
R power
power
5.
is depending upon r power 5. Easy now?
Yes, sir.
Okay. Should we move ahead, Atul, or do you want me to wait?
So I have to write, sir.
Yeah, yeah,
Just
please.
for one.
Yeah, yeah, go ahead, go ahead. No issues, no issues.
Yes, sir. Done, sir.
Done? Okay, great. Let's move to the next part then. So, the next question, right? The next question is from JEE Main 2019, right? So we are taking this question from JEE 2019. I am reading out the question, Atul. Have a look at the question. It says, hello, Atul, can you hear me?
Yes, sir.
Okay, right. So what does the question say? Question tells you that you have a wooden block which is floating, a wooden block which is floating in a bucket of water. So let's draw the bucket of water. Here we have the bucket. Let's put some water into it. So here is the water. Okay. Now there is a wooden block which is floating in this. It says with four-fifth of its volume submerged. This is how it is. Four-fifth of its volume submerged. So the part which is below water or inside it has a volume. Let's say if the total volume is V, then this part, the part inside, has a volume 4 by 5V. Okay, 4/5 of the volume is submerged in it. It says that when an oil is poured, right, certain amount of oil is poured into the bucket. It is found that the block is just under the oil surface with half of its volume underwater and half of its volume in the oil. I'll draw what I'm saying. Now, after this, you pour some oil. You pour some oil into the bucket. Then the condition completely changes. Let's say this is the surface of oil. Of course, oil is less dense than water, so it will be above it. So here we have this entire surface. I'll just draw it, right? This one, this green color part, let this be oil, right? And the other part of it, let it be water, the one which is inside, right? Now, if you want me to draw this over here, let me do that. Correct. So this was water. Same thing over here. Okay. Now, see what's happening. Now what is seen that after the oil is submerged, only one half of the solid is inside the water and the one half is in oil. So if I want to draw it, this time also with the help of a black dotted line, this is how it will look like. Only one half is in water. So now the part which is in water is V by 2, right? And the part which is here in the oil is also V by 2. Initially, the part which was above water, that is in the air, was V by 5. Is this picture clear to you, Atul?
Yes, sir.
Okay. Now what they are asking is find out the relative density of oil. That is the density of oil with respect to density of water. You need to find this. Have you written down the question, Atul?
Yes, sir. Yes, sir.
Now, can you try and figure out what should our approach be for this question, Atul? I have not explicitly covered this concept and that is why I'm giving it here, right? There is a concept called as buoyant force. Do we know about it, Atul?
Yes, sir.
What is buoyant force? We had seen in, I think, one or two classes back. What is buoyant force? Buoyant force is a force. I think you were the one to answer it, right? When you had said it acts in the opposite direction of gravity. Am I correct?
Yes, sir. Rho G H, I think.
Ah, very good. Buoyant force is nothing but a force given as V rho G. It is given as V rho G, where what is rho? Rho is the density of liquid. This V is the volume of the submerged part. I can write this as, or volume of the immersed part. So I'll write it as V in. So are you clear now with the definition? Buoyant force or buoyancy is an upward force which acts on a body. Buoyant force is an upward force which acts on a body which has been submerged inside a liquid and is given by the volume inside the fluid times of density of the fluid into G. Are we clear, Atul?
Yes, sir.
Okay, this is how buoyancy or buoyant force is defined, right? This is how buoyancy or buoyant force is defined. Now, whenever an object is floating, no Atul, whenever an object is floating, this is the condition. Whenever an object is floating, net force on the object, net force on the object is zero. Net force on the object is zero, right? Now, since the net force on the object is zero, tell me what are forces acting on the body in the first case and then the last case. Tell me what are the forces acting on the body in the first case and the second case. Yes, one is buoyancy and the other is the body's weight. Am I correct? One is weight of the body and the other is buoyancy, and the other is buoyancy, right? In the second case, because there are two fluids, so there are two buoyancies. Am I correct? In the second case, there are two fluids, so there are two buoyancies, right? One can be because of oil, and the other can be considered because of water, right? Am I correct, Atul? Clear with this? Okay, great. Yeah. Now, since we know that in case of floating, the net force is zero. So what we are going to do is, in both cases, case 1 and case 2, let's say this is case 1, this is case 2, right? I am going to, I am going to write the expression for net force first. So the net force will be equal to, let's say, W minus B. Here also I'm going to write down net force, or you can write it as B minus W, depends upon you, right? B minus W. Here also we can write F net is equal to BW plus B naught minus W. Correct? Now let's take this expression as zero. Why? Because we have just read whenever an object is floating, the net force on the object is zero. So this will be our expression, correct? This gives us here water, the weight is equal to buoyancy, correct? Weight is equal to buoyancy, right? Let us substitute that expression over here when required. So we will have, you can message me, right, in case the audio is not feasible. Whenever you have any doubt, you can message me. No issues, right? No issues. Right. So therefore we have the buoyancy initially is equal to W. What would buoyancy be equal to? See, we had learned that buoyancy is immersed volume into density of liquid times of G. Let's substitute that expression. Immersed volume. What is the immersed volume initially? See here, 4 by 5V. So we'll write first the expression is immersed volume into density of liquid into G, and weight is of course total volume, right? Total volume into density of solid into G, correct? Now, therefore we have here, instead of volume inside, we'll take 4V by 5. We'll take 4V by 5. So we have 4V by 5 is the immersed volume into density of liquid. G on both sides gets cancelled out, right? And we have, next step is V into rho S. V into rho S. Let's cancel out the V term also. Let's cancel out the V term also. Therefore, we get rho L, right, is equal to, or rho L by rho S is equal to 5 by 4. Correct? Rho L by rho S is equal to 5 by 4. Or you can also write it the other way around. Relative density of solid is given as 4 by 5. Easy. Now, what have we done? Basically, we have taken one of the two equations that we got, right? One was, let's say this was equation number 1, right? And let's say this was equation number 2. So we have expanded upon the equation number 1. Now let's take equation number 2. Let's take equation number 2. What was the equation? The equation was total buoyant force acting on the liquid upwards is equal to the weight acting downwards. Total buoyant force acting on the solid upwards is equal to the weight acting downwards. Let's write that up. We have B O plus BW is equal to weight acting downwards, right? Now, we could have actually dealt in two ways. I could have directly substituted this here, or we can also deal in the way we are doing now. Now we'll substitute the expressions, right? So we have B naught given as, or the buoyancy due to oil. So again, what is the submerged volume in oil? V by 2, correct? V by 2. So we'll have V by 2, right? Into density of oil times of G plus what is the submerged volume in water? It's also V by 2. So we will have plus V by 2 into density of water times of G is given as, what's the weight given as? Total volume V into density of the solid times of G. Density of solid into G. The G and V terms can be cancelled on all sides. So we will have density of oil by 2, rho naught by 2, whole plus rho water by 2 is equal to rho S. Right? Correct? Now, here actually rho W and rho liquid are one and the same thing. So I can replace this rho liquid by rho water. Right? So now let us divide this entire equation by, divide both sides by rho W. See what the expression becomes. Rho naught by 2 times of rho W plus 1 by 2 is equal to rho S by rho W. Correct? What is the value of rho S by rho W that we got? Substitute it over here. What's the value? 4 by 5. Substitute it. You will get 1 by 2 here and 4 by 5 here, right? And we have half into rho naught by rho W. Correct? So we'll write it here that half of rho naught by rho W is equal to 4 by 5 minus half, which is 10, and we have 8 minus 5, that gives us 3 by 10, right? So you have therefore rho naught by rho W is equal to 3 into 2 by 10, or we have 3 by 5, correct? The point is, now we are getting the expression for rho naught upon rho S. What is this? This is the density of, this is the ratio of density for oil upon density for water. This term is basically called as relative density. This term is called as relative density for oil. Relative density for oil, given by 3 by 5 in our case. right? Is the concept clear now, Atul? Just have a look at the question. Any query, let me know. Yes. And instead of 3 by 5, I can also write this as 0.6. So in the question, actually, you were given with 4 options, A, B, C, D. Then you have A is equal to 0.6, B is equal to 0.8, next option. Another one is 0.7, then you have 0.5, right? So you had to choose between them. So the answer would have been again option A, coincidentally. Right? So just go through what we have done until now. What we did, I'll give you a quick revision. So basically, we were given two cases. In one case, there was just water, right? In the other case, there is oil and water. In both cases, the object is floating. In both cases, the object is floating. We were asked to find out if the densities in two cases for water is rho W, right? For oil is rho O, and here density for water is rho W. We were supposed to find out what is the ratio of density of oil and density of water, right? Then whenever an object is floating, right, we understood a concept that the net force on the object is zero, correct? Therefore we wrote the net force is equal to buoyant force minus weight, right? In this case, why? Because see, the net force, let's take upward as positive, downward as negative. So net force is B minus W. What about the second case? In the second case, the funda is now there is no longer case of one liquid. Now we have two liquids present in the vessel. So therefore, buoyancy will be by both of them. Buoyancy will be by both of them. That is, the upward force will be by both of them. Let us take that upward force by water as BW, that by oil as BO. So the total force will be BW plus BO minus of weight, correct? Since a floating object has force 0, I took the weight or the F net as 0 here, F net as 0 here. Accordingly, we substituted the values that buoyancy is given as submerged volume, right? Buoyancy is given as submerged volume or the volume inside VI into rho L, whichever liquid it is, into G. So here we have the case of water. So we took in submerged volume into rho W times of G. Submerged volume in first case is 4V by 5. Here we have V, right? And then accordingly we proceeded in order to get rho S by rho W is 4 by 5. Similarly, on the second case also, we had a change in the submerged volume. See, here the submerged volume there was only one liquid, of course, it was 4 by 5. Here the submerged volume is V by 2 in both cases. So we just write V by 2 in both cases, the submerged volume, and expand to get the answer as 0.6. Correct? Easy to solve, right? Any queries, you may let me know. Yes. Yes,
No,
clear, right?
yes, sir. Yes,
Okay.
sir. Yes, sir.
Do you want time to write it down?
No, sir. No, sir. I wrote it.
You wrote it. Okay, great.